I'm so happy to finally solve one of Mathinity's challenge problems. This is Andrej. He has a fun page where he posts challenge problems every Sunday, so be sure to give him a follow. We're going to go ahead and solve this integral using three things: trig substitution, a trig identity, and King's rule. Okay, let's check it out. So the first step to do is go ahead and use trig substitution. The triangle helps me find my tangent. I found my differential dx, and I found the value for 1 plus x squared. And now we plug in this value in for our x. We're going to go ahead and turn the denominator into secant squared, and then we have our differential. But before we continue, we need to change our parameters. Using the definition for x, when x is equal to 0, theta is 0, and when x is equal to 1, theta is going to equal to pi over 4. So now I write these back into my integral, and I cancel out my secant squared. So here we have the integral in question, and we're going to go ahead and use King's rule, which is going to give you a new integral, and you might think it's going to become a bit more difficult, but we're going to go ahead and use a trig substitution. So now we continue writing our integral, and you'll notice that we have the tangent of pi over 4, which is just going to equal to 1, which is going to give us a nicer looking integral. And now because we have the plus 1, we're just going to go ahead and get common denominators, and you'll quickly see the tangents are going to cancel on the top, giving us a 2 on the numerator. So here's our polished off integral, and we use our properties of logarithms, which is going to give us two different integrals. And notice that this one is the same integral as the original, so we can go ahead and move this to the other side, which gives us twice the integral is equal to some basic integral that we can easily solve on the right hand side. And now we divide by 2 and we find an easy solution to the challenge problem.